Moon is the Earth's closest companion. Both are receiving same amount of energy from Sun. Unlike Earth, which maintains a moderate temperature over much of its surface, Moon swings between extreme heat and extreme cold. Do you know why is that so? A day on Moon lasts as long as 29.5 Earth days. In other words, if you were standing on the surface of Moon, it would take 29.5 days for the Sun to move all the way across the sky and return to its original position again. Area of the surface receiving full sunlight may reach temperatures of around 121 degrees Celsius. Shadowed regions and the dark side of the moon typically drop to as low as minus 157 degrees Celsius. However, the highest temperature ever recorded on Earth is 56.7 degrees Celsius in California's Death Valley. The coldest temperature ever measured is minus 88 degrees Celsius in Vostok Station in Antarctica. Apart from the extreme temperatures, Earth can manage moderate temperature around most of its surface, that is average of 15 degrees Celsius, which is very much feasible for the existence of life on Earth. Why does Moon have these very cold and very hot temperature variations compared to Earth, even though they both are at the same distance from Sun? It's because of the atmosphere that Earth has but Moon does not. Atmosphere is a blanket of gases that surrounds a planet. The atmosphere shields life on Earth from harmful ultraviolet radiation by reflecting most of them back into space. This way, it prevents Earth from getting too much heated up. The planet keeps from cooling down too much at night because of the heat that is trapped in the atmosphere due to greenhouse effect. The greenhouse effect makes the atmosphere act as a blanket around the planet, helping to maintain the appropriate temperature for life. Without the greenhouse effect, we would be living in a very chilly place. The world's average temperature would be minus 18 degrees centigrade instead of the 15 degrees centigrade that we are used to. If this were the case, water on Earth would freeze and life as we know it would not exist. So what is the greenhouse effect and how does it make Earth around 33 degrees centigrade warmer? Greenhouse effect is a natural process that warms the Earth's surface. The greenhouse effect is named by analogy to greenhouses. A greenhouse is a building made of glass walls and a glass roof. Greenhouses are used to grow plants that require special conditions of temperature such as tomatoes and tropical flowers. A greenhouse stays warm inside even during a chilly night or in the winter. But how does greenhouse works? Just imagine you went for grocery shopping in a sunny day, parked your car outside, came back after an hour or so. Sitting back in the car, what would be the first thing you will notice? That your car is much hotter inside than the outside temperature. But can you tell how sun rays are getting in the car but can't escape it? How the heat gets trapped in the car? First thing that you need to know is that all objects absorb radiations. When you stand in sun, you can feel your body temperature rising. You can touch your skin to confirm it. That is because your body is absorbing sun's heat. Second, all objects at non-zero temperature emits radiations. You stand near burning fire, you can feel the heat radiations coming out of it even from a distance. Greater the temperature, greater will be the radiations radiated from a body. Your sun is so hot, it emits radiations that can travel through space. The main types of radiations emitted by sun are infrared, visible light, and ultraviolet. Ultraviolet radiation has a short wavelength. The wavelength is the distance between two consecutive peaks. Ultraviolet radiations are also called UV radiations. Infrared radiations has a longer wavelength. IR radiations are invisible to eye but you can feel them as heat, hence are known as heat radiations as well. Now glass is transparent to shortwave, visible and somewhat UV radiations, but it does not let long wave IR radiations to pass through. When the shortwave UV and visible radiations enter through the car windows, they heat up the surfaces inside the car like seats, dashboard, floor mats, etc. These heated objects release this extra energy in the form of IR or heat radiations that radiates off the hot surfaces. Have you noticed the radiations that have been released are different from those that had been absorbed? The change in wavelength makes it so that the heat can't easily escape out of the car because the glass won't let the longer wavelengths pack through, preventing the radiated heat from leaving. So while getting in was easy, getting out is harder. This means more energy is going in than is getting out and causes the inside of the car to quickly get hotter than the outside. Same is what happens in the greenhouse. Visible and UV radiations enter through the glass of a greenhouse. These radiations get absorbed by plants and soil inside and got converted into heat radiations. Now, heat radiations can't pass through glass. It gets trapped inside the greenhouse, causing its temperature to increase significantly. Earth is not covered in a glass house, but there are some gases in our atmosphere that act like a greenhouse. These gases are called the greenhouse gases, include methane, carbon dioxide, nitrous oxide, and water vapors. The greenhouse gases have the property of absorbing infrared radiations. Oxygen and nitrogen, the major gases in the atmosphere, do not have this property because they have very strong bonds that can't vibrate at all. Greenhouse gases are more complex than other gas molecules in the atmosphere with structures that can absorb heat because greenhouse gas molecules are made up of three or more atoms. When absorb energy, their structure gives them a larger variety of ways to stretch and bend and twist, making them good absorber of energy. These molecules get excited after absorbing IR radiations. They can't keep this energy to themselves forever. They will eventually release this energy to gain energy balance again. Here you can see the molecule of carbon dioxide bending and twisting after absorbing IR radiations. Solar radiation that passes through the atmosphere and reaches Earth's surface is either reflected or absorbed. It gets reflected by polar ice caps or clouds, etc. Reflected sunlight does not add any heat to the Earth system because this energy bounces back into space. However, absorbed sunlight increases the temperature of Earth's surface and the warmed surface re-radiates as long-wave IR radiation. Some of the re-radiated heat that does not got hit by any greenhouse gas molecules passes straight through the atmosphere. If there were not any greenhouse gases in the atmosphere, all that heat would pass directly back into space. With greenhouse gases present, however, most of the long-wave radiation coming from Earth's surface is absorbed and then re-radiated in all directions many times before passing back into space. The infrared radiation strikes the molecule of a greenhouse gas such as carbon dioxide and causes the bonds to bend and vibrate. The molecule gains kinetic energy by this absorption of IR radiation. This extra kinetic energy may then be transmitted to other molecules of same or different greenhouse gas and causes the general heating of Earth's atmosphere. Heat that is re-radiated downward toward the Earth is absorbed by the surface and re-radiated again. Altogether, this cycle of absorption and re-radiation by greenhouse gases impedes the loss of heat from our atmosphere to space, creating the greenhouse effect. Greenhouse effect is something we need to sustain life on Earth, and it has been around for millions of years. So why do we keep hearing about how bad it is? Ever since the Industrial Revolution and especially in the last few decades, human activities like burning fossil fuels, deforestation, exhaust fumes from vehicles, agriculture increase the amount of greenhouse gases in the atmosphere. It means that more heat is trapped in the atmosphere than ever before. This is called enhanced greenhouse effect. It upsets Earth's energy balance, causing a significant rise in Earth's temperature and global warming. Do you know which is the hottest planet in the solar system? Mercury is the closest planet to the Sun. A lot of people think that it is the hottest planet in the solar system. However, this is not the case. Venus, which is the second planet from Sun, is actually the hottest planet with the average temperature of 464 degrees Celsius. Hot enough to melt lead. Why? Because Venus has a crushing carbon dioxide atmosphere that is almost 90 times thicker than our Earth's atmosphere. This thick atmosphere traps heat on the planet and prevents it from escaping back into space, causing severe greenhouse effect. And it makes the surface of Venus hotter than that of Mercury and those of all other planets in the solar system. This is just an example of what a severe greenhouse effect could do to a planet. Save Earth from getting too warm before it gets too late.